Okay, hello everybody. So, part A, what are the critical points of a function? Critical points are those inputs. So critical points are inputs, first of all. That's where they live. They're not outputs. They're those inputs with grad f at that input equals the zero vector. In other words, like 0, 0, like every single component of the gradient is 0 at that point. When I plug in at a specific point, that is a critical point. Okay. Part B. Why are non-critical points not argmin? So if you have a non-critical point, it cannot be an argmin. Why? So non-critical points have, well, grad f at that point evaluated there is not equal to the zero vector. Recall our formula. Linear approximation formula plus the derivative. Well, the derivative in this case is the dot product with the gradient, because our function has just a real number output. Okay. So recall this formula. Taking v equal to, well, some very small movement in the direction of minus the gradient vector at p. So that's a non-zero vector. It's an actual movement. We can just go a very small amount in that way. Gives us a point p plus v. So p plus v. In fact, actually this should be probably in the formula color. I'll continue with words. Gives us a point p plus v, so I move a little bit and I get a new point which has smaller value f of p plus v. I mean, that shows that p is not the argmin. That shows p is not an argmin, because we just found a nearby point that has smaller value, so then p is definitely not the argmin. Okay, and this is because when we do a vector, if I put this in for v, then a vector dot product with its negative is going to be a negative number. So this whole thing is a negative number, which means, f of p plus a negative number will give a smaller number, proving that this was not the smallest number. This one we can make smaller just by moving to this point. Okay. End. Okay, part C. What nonlinear equations determine the critical points of our function g from equation 1? Write these equations explicitly. So here's the function g. It's equation labeled 1. And so what's grad g? Well, grad g is a map from R2 to R2, taking xy to the point. In fact, this is all a formula, right? Well, to what point? Well, the partial derivative with respect to x, and then the partial derivative with respect to y. And so let's do the partial with respect to x first. 0, this one gets a 2y squared, minus 2x, 0 and 0, comma. Now partial with respect to y, that'll give 0, 4y to the third, 4xy, 0, minus 2/3 y, and 0. Okay. Okay, so that's the gradient. And now, what are the equations? Well, the equations, the two nonlinear equations whose solutions give critical points are, well, what are critical points? Where the gradient is the zero vector. Okay, well, here's the gradient. So when is it the zero vector? So let's write down the formulas. 8x to the third plus 2y squared minus 2x equals 0. We force this to be true. And we force 4y to the third plus 4xy minus 2/3 y equals 0. So these are two nonlinear equations in two unknowns, or unknown variables, namely the variables describing our point P. We'd like to find those critical points P, so we need to solve this system of two equations. Okay, write these equations explicitly. Done. D, add any relevant labels to the picture below. So I need to label this picture. Okay, so first, we have two equations and we have two curves. So I'll put an arrow here. Well, maybe in red for words. The blue curve are solutions to the first equation. Okay? And then the red curve are all solutions to the second equation. Okay, so that's a blue curve, that's a red curve. But the most important thing are solutions to both equations at the same time. What are those points? This point is on blue and red curve. This point is on the blue and red curve. This point is just on the red curve, so it's not what we care about. This point is on the blue and red. This is on the blue and red, on the blue and red. This point is just on the red, so we don't care about it. This point is just on the blue, we don't care about it, but this is on blue and red, blue and red. 4, 5, 6, 7. The 7 points on both curves are solutions to both equations. Hence, they are critical points. They're the points that have a chance of being the argmin. Very, very nice. Solving system of equation coming from the gradient vector equals the zero vector will give us the critical points. And the critical points are the points that at least have a chance of being an argmin. Okay, I've got words, pictures, and formulas.